Good day everyone! Today we will talk about higher order derivatives, presented by the House of Gamaliel from 11 ATA. First, let's define what are higher order derivatives. A higher order derivative refers to the repeated process of taking derivatives of derivatives. It is applied in sketching curves, motion problems, and other applications. Now, these are the notation for higher order derivatives. It is written using a small letter f and an apostrophe. The apostrophe determines the number or the order of derivatives. First derivative, second derivative, and third derivative. Moreover, the first derivative would come from the main equation, and the second derivative will come from the first derivative, and the third derivative will come from the second derivative, and so on and so forth. In short, there is no shortcut when finding higher order derivatives. You have to first find the first derivative before you can find the second derivative. You have to find the second derivative before you can move on and find the third derivative of the equation. In order to better understand, let's try solving problems involving higher order derivatives.
To better understand higher order of derivatives, let's look at a few examples. First, let's solve for the third derivative of the function 14x cubed minus 17x squared plus 32x minus 5. Looking at this function, we can use the rules of constant rule, constant multiple, and sum and difference rule. By applying the appropriate rules for each term that we've learned from previous lessons, we can say that the derivative of 14x cubed minus 17x squared plus 32x minus 5 is 42x squared minus 34x plus 32. Now, for the second derivative, we would simply get the derivative of the first derivative. Very simple. Looking at the first derivative, we can apply the rules of constant multiple, constant rule, and the sum and difference again. To get the derivative, we would again apply all the appropriate rules for each term, giving us 84x minus 34. Now, for the third derivative, we will again get the derivative of the second derivative, giving us the simple 84.
Hello everyone, today we're going to determine which derivative of the function first equals to 0. We start with the function f of x equals x to the fourth power minus x squared minus x. Taking the first derivative, we apply the power rule. The first derivative of x equals 4x cubed minus 2x minus 1. Since this is still a function of x, we will proceed to the next derivative. The second derivative of x equals 12x squared minus 2. It's still dependent on x, so we will continue. The third derivative of x equals 4x. Since it still continues x, we differentiate again. The fourth derivative of x equals 4. Since these results are constant, so we differentiate once more. The fifth derivative of x equals 0. We reach a derivative that equals to 0. In conclusion, the fifth derivative of x of f of x is the first to equal 0. Thank you for watching.
So for this equation, we're going to find the second derivative of 6x cubed minus 4x squared plus 5x squared minus 2. So first we're going to find the derivative of this equation. Derivative equals to parentheses 6x cubed minus 4x squared plus 5x squared minus 2 close parentheses. Then for the first derivative, 6 times 3 is equal to 18 and minus 1 the exponent, so it will be 18x squared. So next, negative 4 times 2 is equal to 8 and minus 1 the exponent, it will be negative 8x. And repeat the process, so it will be 10x. And the last is negative 2, that is constant, it will be 0 and 4 are second derivative. So repeat the same process and the final answer will be 36x minus 8 plus 10.
Now for the last problem, identify which order of derivative the equation will equate to 0. The equation is f of x is equals to x raised to the power 4 minus 3x squared plus 7. The rules we're going to use are power rule, constant rule, and constant multiple rule. Now for the first derivative, we're going to find the derivative of x raised to the power 4 minus 3x squared plus 7. So the derivative of x raised to the power 4 is 4x cubed minus the derivative of negative 3x squared is 3 times 2 is equal to negative 6x. So our first derivative is 4x cubed minus 6x. Now for the second derivative, since we got 4x cubed minus 6x from the first one, now let's find the derivative of 4x raised to the power of 3. 4 times 3 is 12, 3 minus 1 is, and then the negative 6. Simply just remove its variables since it's just 1 minus 1, 1 raised to 0. So we have 12x squared minus 6 left for this. Now moving on for the third derivative, we have, since we got 12x squared from the previous derivative, now we're going to find the derivative of 12x squared. The derivative of 12x squared is simply 2 times 12 is 24, and negative 6 is just 0. So for the fourth derivative, we only have 24x left. And for the third derivative, we only have 24x left. For the fourth one, we simply need to remove the variables since x raised to the power of 1 minus 1 is 0. So we only have 24 left. And for the fifth one, since 24 is a constant number, we simply make it 0. So the order of derivative for the equation to equate to 0 is 5.